Hello, this is Miss Seeley. Welcome to the review of Math Makes Sense Unit 3, Decimals. So in Lesson 1, this lesson was about numbers to thousands and beyond. Decimal numbers are located on the right side of the decimal. Decimal numbers are put together in groups of 3 digits, and they're separated by spaces, not commas like we do in whole parts of numbers. To say a decimal number, we say the whole number, then we say "and" for the decimal, and then we read the decimals as if they were a whole number, and we follow with the name of the place value of the farthest right digit. Each decimal place is 10 times greater than the place to the right, and here's an example of a decimal place chart. Okay, starting with the tenths, the first place to the right of the decimal, then hundreds, thousandths, 10,000ths, 100,000ths, and millions. Okay, similar to whole numbers, we have the same types of forms. There is standard form, which is kind of like the regular form of a number. There's expanded form, which is as a sum of each place value, but you don't include place values with a 0 digit. And there is number word form, where you have digits and the name of the place value of the last digit in words. Finally, you have word form, where there are no digits. It's completely done in words. Moving on to Lesson 2, that's when we started estimating products and quotients, which are the answers to multiplication and division questions. So to estimate an answer to a multiplication question, where one of the factors is a decimal number, there's 2 different ways we did it. The first one was front-end estimation, where we ignore the decimal part of the number. For example, 3.54 times 2 becomes 3 times 2 equals 6. Benchmark estimation is a second way. Then we round the decimal number to the nearest whole number. We use our rounding rule. If it's 4 and below, it goes down. If it's 5 and above, it goes up. So this time, 3.54 times 2 would round up to 4 times 2 to get 8. There's a note here that says, note that these 2 methods give different answers, but that's okay because they're both reasonable estimates. Okay, moving on to estimating an answer to a division question where the number we are dividing is a decimal number. Here is your strategy. You're going to use a compatible numbers for estimating. You round the dividend to the nearest multiple of the divisor. So if you have 17.26 divided by 6, you think of the closest multiple of 6 to 17.24, which is 18. So you round it to 18 divided by 6 and get 3. If you have the example 4.95 divided by 6, the closest multiple of 6 would be 12. So you would round 14.95 to 12. If you round a decimal number down before you multiply or divide, your answer is going to be an underestimate. If you round a decimal number up before you multiply or divide, your answer is going to be an overestimate. In Lesson 3, we started multiplying decimals times whole numbers. We used a counting decimals places strategy. The first thing we did was ignore the decimals and we multiplied the factors as if they were whole numbers. After we got the answer, you count the number of decimal places in the factors. And then, step 3 is to assign the same amount of decimal places to the product or the answer. Okay, we used the exact same strategy, counting decimal places, in Lesson 4. So then we moved on to a new topic, Lesson 5, dividing decimals by whole numbers. To find the answer to a division question where the dividend is a decimal, the dividend is the number inside the box, here's the steps. We call it the moving the decimal up strategy. You place the number you're dividing in a division box, and you put the number you're dividing with on the left side. Step 2 is to move the decimal straight up from the dividend into the quotient. Be careful to put the correct number of places before the decimal. Step 3 is to complete division as usual. And step 4 is to, instead of having a remainder, you add as many zeros as necessary to the end of the dividend so that you can continue to divide until the remainder is 0. because adding zeros after the decimal place does not change the number. We always imagine decimal numbers with infinity zeros behind them. Lesson number 6, it says, sometimes the digits of the quotient are never ending, and you cannot get a zero remainder. These are called repeating decimals, and they are indicated by drawing a repetend bar over the digits that repeat. So instead of writing 1.2222222, you would just write 1.2 and you put a repetend bar over top of the 2. Lesson 7, we use the exact same strategy as lesson 3.3, and lesson 8 was a strategies toolkit. So that is all of the concepts to review for Unit 3. Good luck on your review questions.